Hello and welcome to the first feedback video of the March Wave exams. This is not a blockbuster, I think you've heard me say before. You're not intended to watch it from start to finish. Zoom on to the first place that you need a bit of assistance with your corrections, then have a look what I had to do and see if you can correct it from there. So first up, a little bit of work on powers. So what does 2 to the power 4 mean? Obviously 2 times 2 times 2 times 2, and so therefore I make that 16. The classic mistake there, of course, is to just do 2 times 4, but it needs to be repeated multiplication of 2's. Onto some decimal calculations. Never try to go across the page. We're going to use columns sensibly here. So 16.4, take away 3.92. I don't like having blanks there, so let's pop that in there. I can't do 0, take away 2, so I've borrowed. 10 take away 2 is 8. 3 take away 9, and that, so I'm going to borrow again. 13 take away 9 is 4. 5 take away 3 is 2. 1 take away the 0 there, so 12.48. Then we need to add the 7.8. I'm going to pop a 0 in there because it just feels better to have it like that. 8 add 0 is 8. 4 add 8 is 12. So let's carry that 1. 9, 10. For that total, I've got 1 to carry over. So 20.28 is your final answer. So things to be careful of here is make sure that you accurately put your ruler on the end of the line. You might want to tip your page up, so rather than it being on the diagonal, it's horizontal. That might be easier to use. There is a bit of leeway there. They tend to give you 2 millimeters either way, so there is a little bit of inaccuracy allowed there. I'm not going to give you the final answer because on my screen it's a different size, so I can't actually give you those. Same with the protractor use. Make sure that you go for the middle of protractor and place it on there. So by the middle I mean the little cross piece in there. That should go on to here, and so therefore you sort of end up with your protractor going along the 0 there as it goes round, and then very accurately reading off the scale. And of course we can see it's an acute angle, so if you're ever unsure which scale to use, then you can look carefully there and see whether as long as it's the one under 90, and again a degree or 2 leeway tends to be the thing there. Okay, an endless set of correct answers available here. Write a number in each box to make the statement correct. Is essentially as long as this one is bigger than this one, then you've done it right. So 10, 1. The big piece of the inequality goes next to the bigger number, and then the small piece goes to the smaller thing. So any value, doesn't have to be a whole number, anything where the first number is smaller than the second, you have done it. Number scales are up next, and so let's count how many pieces. 1, 2, 3, looks like 4 sections, isn't it, to get from 2 to 3. So I think, well, halfway in between that's going to be 2.5, and then halfway in between there is going to be 2.75. The temperature, again, it's about scale, this, isn't it? 1, 2, 3, 4, 5. So it is what I suspect. It's going down in 1 degree each time. So that there would be a temperature of -1. Rotational symmetry, we're turning it around and looking at how many places does this look the same. So essentially the circle would have endless rotational symmetry, so it's really dictated by the triangles. They're all identical and they're pointing in the same direction, just checking yes they are. So then it comes down to how many are there, because that's the number of positions where this would look the same. So 1, 2, 3, 4, 5, 6, 7, 8. So the order of rotational symmetry is 8. Simplification, so 7a plus another 3a would be 10a. take away 4a, and I end up with 6a overall. And then factorise, factor number that divides in, so what goes into 6 and into 20. 2, anything bigger than that? No, it's always worth checking, of course. So 2, and then what do I multiply 2 by to make 6y? That is 3y. And secondly, what do I multiply 2 by to get 20? Then that is 10. I like to sort of do it in that multiply way. It feels a bit easier somehow than doing the division. Expanding or multiply out, you could get either as an instruction in these. They've been nice and given us multiply out. So x squared times 4 would be 4x squared. X squared times x, so that's times another x, so that's going to change the power of the x, will be minus x cubed. Time calculations have that habit of catching people out all the time, so you've got to be really careful, because of course people start adding things, looking at hundreds, but 60 minutes in an hour. So let's do the first couple of times. So 20 min plus 40 min is, of course, 60 minutes, which is an hour. At this stage, just want to double check my question. Yeah, I want to give my answer in hours, so that's quite nice. And I've got an additional 1 hour 30 minutes. So I add that on, I'd get 2 hours 30 minutes. And I'm writing the answer in hours, so that's 2.5 hours or 2.5 hours, isn't it? If you wrote it as 2.5 as in used the fraction, that is fine too. So again, doing another time calculation. The first lesson starts at 9:10. Each lesson is 60 minutes long. So if that's the start of lesson 1, then the start of lesson 2 is going to be at 10:10, so plus an hour there. The breaks between lesson 2 and lesson 3, so I'm going to have another hour for lesson 2 to happen, so that's 11:10. Then I'm going to have my break of 15 minutes, so 11:25, and then I'm going to have my final hour to find out when lesson 3 ends, would be 12:25. The arrow by arrow approach I found much better. If you start using column methods with time, then it's tempting to sort of lose track of the fact that it's 60 minutes in an hour rather than 100, and it can sort of complicate matters. Right, so we start with a tally chart. Doesn't tell you to do anything with that, but it seems sensible to me. They've set it out nicely. Why wouldn't I start by totalling that and just double check? 1, 2, plus 10 is 12, 13, 14, 15, does add to 20, so I haven't done anything silly there. So then the first task was to draw a fully labelled bar chart to show this information. So I'm thinking of a scale. It makes sense, I think, to have the bottom there, and then going up this side here, we're going to have the frequency. You would do it, I hope, with a ruler. So we've got frequency here, and that would be 1, 2, 3, and so on. And then we have the different continents that the person played in. So it's important that let's make sure we do that. And then what's our first one? Africa. And it is a frequency of 1. There we go. It's discrete data, so I don't want blocks joined up. Asia is also 1. Europe is 10 gigs there. Okay. North America next. That would be absolutely fine to label that up. It's very clear. And South America labelled next, going up to a height of 5. So just to let you know from the mark scheme, 5 bars drawn to the correct height in any order gets you a mark. You've got to have the frequency axis correctly scaled, starting at 0, with at least 2 numbers given. So I guess there we are. Let's make sure we've got our 0. It is starting from 0 just from the scale that I've used, so that's quite clear. And then we've got labels on each of our bars. They're all of equal width, got gaps in between and so on. Okay, so that's fully labelled as required. What fraction of the 20 concerts with South America? So I want the answer to be a fraction. So I'm going to form my fraction first. Then I'm going to follow the instruction that says give your answer in the simplest form. 5 is a factor of both of those numbers, so divided by 5, I get 1/4. With a question like that, don't try and write down the simplified version. Just get that fraction written down first of all, and then do any simplifying as necessary afterwards. Okay, so I can only use plus or times signs. So let's see, if I was to add them, you might want to do this sort of question in pencil, I guess, to get you started. 3, 6, 10. Yes, that's a multiple of 5. I'll leave that as it is. I guess if I then do, I could do, thinking 1 times 2 is 2, times 3 would be 6, then add 4 would be 10 again, wouldn't it? So that does work. Got to be careful with my bod masses as well. So if I was to make that a multiply, so 12, that would be 24. I need to then add 1 to it to make the 25. Just looking at other options, because you may have done other things, so there's often more than the options given there. If I was to put a times there, so that makes 12, and I've just thought if I add those I'd get 15, so that would also work. So any of those 3 would get you the marks. On to question 10, all about perimeter. So a triangle has perimeter 32. Okay, it doesn't say it's an equilateral triangle, does it? So I can't assume that. It looks a bit wonky. That isn't a mathematical term, I'll just call it that. Square has perimeter 40. Now I do know in a square they're all equal, so they would all be 10. 2 sides of the shape are put together to make the pentagon, work out the perimeter. So that would be 10, that's 10, that's 10. That wouldn't be part of the perimeter, I know, because it's inside, but that would be 10. So on here, if I go back to there, 32 take away 10 is 22. I don't have a way of sort of finding out which bit is which, but it doesn't really matter. I just know that journey up and back down again would be 22, wouldn't it? So therefore, the perimeter would be the 22 plus 10 plus 10 plus 10, which gives me a total of 52 centimetres, I guess, there, as that's what's given in the question. Okay, so if you work 10 hours, get £90, so time, pay, 10 90. So if I worked for 5 hours, it'd be 45 and 15. Adding those together, or times that by 3, however you want to do it, you would get £135 because assuming there isn't any sort of tax there that happens. But as soon as you've paid us or earned a certain amount, this is exactly how tax works. You may well end up paying tax. So Eric is paid an extra 50p per hour. Okay, well, hang on a minute. Let me go back and have a little look at that. So the hourly pay, so for 1 hour, that would be £9, wouldn't it? So the extra 50p per hour would be 9.5 or £9.50 if it's money is a sensible way of putting it. He pays £8.90 in tax. What does that tell you about the amount he receives? So is it more or less than expected? So in part A, the amount that he expects to receive is 135. So we want to see if it's gone up or down from that. So it was 15 hours worked. That's what we had from part A there. So I want £9.50 times 15. So I can do it as 10 times £9.50 would be £95. 5 times £9.50 would be half of that. So half of 90 is 45. Half of £5 is £2.50. So I'll make that £47.50. So if I add those together, then I'm going to have, £142.50, I reckon. But then he has to pay £8.90 in tax. So now let's do that subtraction. 0 take away 0. Can't do 5 take away 9, so I'm going to do 15 take away 9 is 6. Can't do 1 take away 8, so I'm going to do 11 take away 8, which is 3. That's become a 3, so 3. So he expected to get £135, but only got £133.60, so it is less than expected. And same rules apply in terms of AO2, folks. You've got to do the justification. This bit here is the important bit, not the ticking of the boxes, but do make sure that you do tick a box, otherwise that's a silly way to lose a mark. So 6 whole numbers, these sorts of things, and see how the answer's set out. I like to do that to start off. So I've got 6 numbers, and let's start looking what we'd know. So first rule, the median has to be 10, but hang on a minute, I've got 2 middle numbers. So the only way, I could have loads of 10s. So I could have a 10 and a 10. But if I had a 10 and a 10, the mode has to be 11. That wouldn't give me enough space to have enough 11s, would it? So the only other way I could do that is to have 9 and 11 there. I need at least another 11. And I need my range to be 4. So what about if I did another 11, and then if I count down 4, I would get to 7. And then I guess that can be filled in. I could have a 7 in there, that would work. An 8 would work in there. Or I could have a 9, because that would still make 11 the mode. Yeah, so I think the 7 and the 9 are fixed there. And then we've got different options, so on. So, knowledge of names of shapes. Even number of sides. So, 2, no, that isn't going to work. 4, 6, 8, 10, 12, and so on. More sides than a square, so can't be 4. Fewer sides than a decagon, dec meaning 10, so that, and therefore I think we've got 2 options. Hexagon is the name for a 6-sided shape, octagon for an 8-sided shape. Either of those is fine. So the outcome for drawing graphs tends to be better if they give you a table. Well, if they don't give you a table, guess what, folks? Draw yourself one, and then it's going to be the same sort of thing, isn't it? So x and y, but what x values can I choose? Well, let's have a look what we got down here. We can have -1, 0. What does it go up to? 1, 2, 3. And there you go. That's probably a much easier starting point, isn't it? I don't like negative number calculations compared with positive ones, so therefore I'm going to start at the positive end. That's the rule that links the x and the y numbers. So if x is 3, 3 times 3 is 9, take away 1, that gives me 8. If x is 2, 3 times 2 is 6, take away 1 is 5. If x is 1, 3 times 1 is 3, take away 1 gives me 2. And we can probably start seeing what's happening here. We've got a pattern that we're following. 3 times 0, take away 1 is -1. It's going down in threes, isn't it? I can see that. And you can do that if you wish. So 3 times -1 is -3. Take away another 1 gets me to -4. But we needed to draw that graph. So 3, 8. So you take the first number, the second number, turn it into a coordinate. You don't have to write that down if you don't want to. We're just showing where it comes from. 2, 5. 2 along and 5 up, of course. 1, 2, 0, -1. And 1, -4. And we should hopefully realise that that should be in a straight line, and it is, so I'm happy that I've probably done the right thing. And then you must join them up with a straight line there to get the final mark, because the graph isn't just the points, it's the line is the graph that you need. Fraction calculations, noting we've got to leave our answer as a mixed number, but that's our answer. So let's start first of all with the fraction calculation. Of course, when adding fractions, I need a common denominator. So 6 does go into 12, so actually it seems sensible to have our aim of putting them there with 12 as our denominator, so that doesn't need to change. 6 has been multiplied by 2 to get to 12. So then we do the same to the numerator. So 5 multiplied by 2, get to our 10. So 10 twelfths plus 7 twelfths is 17 over 12, which is a top-heavy fraction, which is what I was expecting, because remember we said, are we going to do our answer is a mixed number. How many 12s go into 17? Well, it goes in once. What have I got left over? 5. So therefore 1 and 5 twelfths would be our final answer. So doing a reflection next, our point A. Remember, if you stand in front of a mirror, then your reflection to the mirror is the same distance as you to the mirror, isn't it? So therefore, I go for a walk and hit the mirror. That's 1 square across. So therefore, that would be the new point of A. And we want the coordinates of that reflected point. So that would be 3, 2. The equation of the line of reflection. So if you think of the points on that line, that point there would be 2, 1. That point there would be 2, 2. That point there would be 2, 3. What you can see is that first number is 2 all the time. That's the x number, so x equals 2 is what you want there. Oh, paying tax again. So Harry this time is paid £800 a month. A tenth you have to pay for national insurance, and a fifth he then pays for tax. how much does he have left? So first of all, a tenth of 800 is 80, so that's the national insurance contribution that is made, and a fifth of his pay is tax. Okay, so it isn't a fifth of what's left, it is actually a fifth of his pay. Isn't quite how it works in actual pay. They do the national insurance first, but anyway. A fifth then of 800, so 800 divided by 5 would be 160. And so therefore the amounts that his reductions, as we call them, would be £240, but that isn't what we were asked for. It's how much does he have left to spend each month. So it would be 800 take away 240, so therefore that would be £560 left each month. Okay, so it's non-calculator paper, so we need to crunch through these various calculations. So, square root of 121 is important that you know your square numbers, please, from 1 times 1 all the way up to 15 times 15 is the recommendation. So therefore, instantly we should know the square root of 121 is 11. That's the first mark allocated. Then we need to apply the rules of BODMAS within what's happening with our bracket there. So we'd do the multiplication first, so that's 13 take away 10 squared. So we haven't finished with the bracket yet. 13 take away 10 is 3, so I need to do 3 squared. 11 take away 9, and therefore we have a final answer of 2. Shouldn't be with a pound sign there. If you chose the negative version of root 121, so it's also true to say that negative 11 is the square root of 121, because negative 11 times negative 11 is 121, and therefore the other accepted answer is by doing negative 11 take away 9, and so the mark scheme does allow that one as a correct answer too. So a bit on set notation, the A, N, B, so if it said what's the probability of that, it's the probability of A and B occurring. So it is that one there, nice little multiple choice. Just while we're at it, things that were useful to you if they crop up. Not A would be an A dash, and so that would be something like that. All right, so the not a dash or a hat is fine for those sorts of things as well, but A and B is the answer there. Okay, looks a bit daunting. We've got 2 graphs to do here. So the whatever amount is raised, I will add double that amount. So if Salma raises 20, Mum will give 40. If Salma raises 100, then Mum would give 200. So we'll do a graph of that. So if Salma raises 100, Mum would give 200, and 20 would be 40, so that's 2 squares up. You can double check, but we can also do 40, double it, you get 80, and you can see quite quickly, hopefully, you get yourself a straight line, so you don't have to put all those points in as long as you've got at least 2. And it should go through 0, 0, because if nothing is raised, then Mum won't add anything. So there we go. Just tidy up a little. And secondly, the amount and then the total. So if Salma raises nothing, Mum puts nothing in, the total would be nothing, so 0, 0. that would be a total of 60, wouldn't it, for £20 for Isalma. So that's 3 squares up. 100 would get us to 300. And you can fill in the gaps in between, but essentially we know it's going to go up in a straight line, so you can go from there. Again, tidy that up. Okay, so exact values, it's becoming a real favourite. It used to be really rare for that to come up, but it is examined all the time, so you may want to invest some time doing that. Learning those, sorry, so cos 30 is root 3 over 2. That's what we're after there. And now on to question 22, looking at some powers. So 3 to the 12 divided by 3 to the 5. So we do a subtraction, don't we? So 12 take away 5 is 7, so that's 3 to the 7, divided by 3 squared times another 3 would be 3 cubed. So that's going to give us 3 to the power 4. Be careful with this though. It says work out the value, so it doesn't say just simplify it. It actually wants the value, and so therefore we need 3 times 3 times 3 times 3, which would give us 81. On to graphs for the next, so real different topics all on this page. So equation of the line parallel to, so the thing that tells you the slope, the gradient, is the number of x's. So y equals 5x, you could have that, or any other values, 5x plus 1, 5x take away 3, y equals 5x plus 92. As long as you have the equation of the line, so you must have y equals 5 and x, and then you can put the number value on the end. The one thing you can't do, of course, is put plus 2, because then it wouldn't be parallel, it would be that line. So question 24 is using the scatter diagram. This scatter diagram shows positive correlation. Describe the relationship between the downloads, so it's describing the relationship, not just saying what type of correlation it is. So as the number of downloads increase, the CDs sold increase too. So anything that indicates as one thing goes up, the other one goes up. You could do it the other way, to be fair, as the number of downloads go down, the number of sales of CDs go down, but anything of that type for the relationship is fine. So the company earns $250 for each download, 3 for the CD. They released another album. First day it has 9,000 downloads. So for 9,000 downloads, let's see what the expected number of CDs sold would be. And that looks like it's going across. Each square's worth 200. So I reckon that would be 5,400. Okay, so let's see how much money they made, shall we? So 9,000 is for the download times the £2.50. So how do I do that without a calculator? Well, 2 lots of 9,000 is 18,000, and then half of 9,000 is 4,500. So adding those back together, I would get 22,500. And then I want the amount for the CDs, so 5,400 times 3. So I'm probably going to do that like that, am I not? 4 times 3 is 12, carry the 1. 3 times 5 is 15, so 16,200. So adding that up, overall, £38,700. Sounds good. I'm going to go and record a record. So in question 25, you're actually given some information that might sort of kickstart your thoughts of how to do this. Remember, your approach for finding percentages of amounts on a calculator paper is different from non-calculator paper. So with this one, we're likely to do the sort of breaking up method because it's a non-calculator. Okay, so if 10% is 210, that's nice of them to tell you, but I guess that's the easier bit, isn't it? 40% would be 4 lots of that, so 4 lots of 210 would be 840. I don't really want to go straight to 3%. I'm going to do 1% first, so that's going to be that divided by 10, so that's 21. 3% would be 3 lots of that, so 63. And so therefore the 43% would be 840 plus the 63, which is 903. You could have ignored the first line, it just asks you to work that out. So you might be somebody who'd rather do 2,100 times 43 divided by 100. So that's the same as doing 21 times 43, do that long multiplication, and hopefully you should then end up with the same thing. So we have the graph drawn for us of this quadratic 5 plus y equals 5 plus 3x minus 2x squared. We want to find out where that is equal to 0. So it might look complicated here, but actually we just want to know, where does it cross the x-axis? Where is the height 0? So that happens at -1 and 2.5. Any order there would be fine to get the 2 marks. Right, so area of these two shapes. They're based on circles, but fractions of a circle. So area P is 3/4 of its pi r squared. And that would be 3/4 times pi times 20 squared. 20 squared is 400, so we want 3/4 of 400 pi. So 400 divided by 4 is 100, times by 3, I reckon that's 300 pi. Area Q is 1/3 of their pi r squared, which is pi r 15 squared. That's what said we need to know our square numbers. So it's 1/3 of 225 pi. So what's 225 divided by 3? Either you know that, or if you're not sure, then do the longer method, I suppose. So how many 3's go into 2 doesn't. How many 3's go into 22? That would be 7 times 3 is 21. So I've got 1 left over. And so you can see we'd get 75 pi. So the question was, how many times bigger is the area of P than the area of Q? So one's 300 pi and the other's 75 pi. So how many times does 75 go into 300? I think it's easier to count up into 75s personally. So we already know that one, I suppose. And therefore it's going to be 4 lots, isn't it? So standard factorising question here. We've got x squared, x and number terms. So I know from experience it's going to be of that format. That drives the sign in the brackets, it's negative, so therefore I know I'm going to have 1 positive and 1 negative number there. So what numbers multiply to make negative 15 and have a difference there of 2? So 1 times 15, no. What about 3 and 5? That seems like sensible. So is it 5 and minus 3, because that would multiply to make minus 15, or is it minus 5 and 3? I need that calculation to end up with a positive 2. So 5 take away 3 does give me 2, and minus 5 plus 3 would give me minus 2. So I don't want that one. So it's a positive 5, negative 2, and that is the final answer. You can give the brackets in either order, that would be fine. Standard form, again, is a very common question. An ordinary number here, so 3, and then I want 1, 2, 3, 4, 5 to zeros there to make the number that I want. So moving on to part B. Ooh, sneaky, they're putting a bit of ratio in there as well. So oh, look what we had to do in part A. So maybe that's a bit of a hint that's going to be helpful to me. So that would be 3 times 10 to the 5. Then with our ratio, sorry, I should go into that. So 5 times 10 to the minus 1. So that would be 0.5. Because of the fact that it's a negative power. The format I want is that, so I'm going to times by 2, which makes that 1, and therefore I must times this by 2 as well. The question was given in standard form, so I guess I should put it back there. So therefore that would be 6 times 10 to the 5 to the 1 there. So 6 times 10 to the 5 is what we need. You can use the solutions here, hopefully to do your corrections, but go back and use these again in time. If you want to retest yourself, test your understanding, then you've got those solutions there. I hope that was useful.